Hello, welcome to this video. In this video, I'm going to present an AI agent called Voyage Intel. It is an autonomous agent that transforms shipping market intelligence into real-time executive decisions. Voyage Intel is powered by Cloud AI and designed to eliminate the guesswork in maritime chartering decisions. The time used to predict the recommendations could be hours or days, but with this tool, we can make it within minutes. Speed, accuracy, data driven, so many factors are considered while building this application. It's still in the phase zero, I would say. So this is the UI of the application. Voyage Intel. I just added some tagline: shipping market intelligence agent, real-time market analysis recommendations. Okay. The shipping industry moves $14 trillion in global commerce annually. Chartering decisions when to deploy vessels, which routes to prioritize, whether to hold or deploy, are often based on fragmented data sources and manual analysis. Voyage Intel solves this by analyzing multiple data sources. In this case, I used three data sources, which is Bloomberg, Clarksons, S&P Global. This agent generates recommendation based upon these three data sources and also the days. Here I just used only the last 10 data. In fact, this data is not a real-time data. I just mimicked, created a mock data. Okay. Since it's a phase zero, I'm just making this as a sample uh, data. This tool can be used by many fleet management companies, shipping brokers, maritime asset managers, logistics optimizations for those purposes. Okay. So these three data sources have got a lot of data actually. But say for example, this is a Bloomberg. So on click of this Bloomberg, you will see the Bloomberg related data. Okay, this is only a minimal data I'm using. There's something called BDI index. I think it starts with Baltic. I don't exactly, but I find something in the Google. BDI index. Okay, if the number is bigger, like more than 3,000, looks like it's a good figure. Anything less than 3,000, it's ordinary, and anything less than 2,500 is not a good number. Okay, not a good number to take any business decision. Okay, and we have some chartering rate. This is a rate of the vessel, and this is a Panamax vessel, and this is a Capesize vessel. So this is all about Bloomberg. Likewise, we have Clarksons. Uh, Clarkson actually is a broker sentiment as voice of the market. You can say you'll understand what brokers are actually seeing in real deals. Okay, so broker could be maybe pessimistic or neutral or optimistic. Okay, and then also it helps to know the vessel availability, like how many ships are currently available for the charter. So here you can see the parameters under the Clarksons. And there's something called broker sentiment: optimistic, neutral, and pessimistic. So these are the values I'm considering to recommend to the user. And finally, I have something called S&P Global data source. This one, okay. S&P Global provides forward-looking forecast and risk assessment, whether the forecast is bullish, neutral, or bearish. It also gives us some confidence percentage, 0 to 100 percentage, and some geopolitical risk of moving the vessels. Okay, so if I click the S&P Global, you'll understand what I mean. Yeah, here it is. It is the geopolitical risk, geopolitical details, and all. And there's something called forecast confidence. So I'm using this parameter. Anything more than 80 percentages, it is good. Between 60 to 80 is mixed. Below than 60, it is not good. So these are the three data sources I use to build this tool. Okay. Um, let's try. Okay. So now I'm going with the last 7 days data. Maybe I will reduce to last 3 days data. Okay. Not the recent, the first 3 days. Okay. The last, say for example, we have a data for the 10 days. I want to know how the market was behaving in the first 3 days. So with this, so as soon as you select the days, the data will be displayed based upon the dates range. So you can see the days 74, July 25, July 26, July. For these 3 dates, this is the uh, data. For Bloomberg, the BD index is less than 3000. Um, Clarksons is also not great, pessimistic and neutral only. S&P Global, moderate, weak and all. Okay, so with this first 3 days data, I'll go for the recommendation. So recommendation. This recommendation is coming from the agent. I'm using the Claude. So Claude is recommending. So I'm not trained my model here. Rather, I given a prompt. I defined a prompt earlier by defining the three different data sources. Each data source like Bloomberg, Clarkson, S&P Global, each of the important parameters. Okay, with those parameters, I define the system prompt, and based upon that prompt, it is trying to give a is recommendation. So in this case, for the first 3 days data, what it says is all three data sources are available and point to mixed market. So hold off, hold off. It says don't go for a trade. Hold off on major deployment and wait for clearer signals before committing more vessels. Deploy only a small number while monitoring the market. So it is giving us some indication, don't proceed, something like that. So this is all the reason why it says, because Bloomberg signal it's bad. The BDA index is 2,900, is below 3,000. Clark signal is mixed. Broker sentiment is neutral, and then S&P global signal is also mixed. Confidence score is just 75 percentage. So these are the three sources considered, and the analysis period is first 3 days. So it's confidence. The Clark's confidence level is 60 percentage. Medium risk recommendation. Please wait. This is the recommendation. Okay. If I change this to, like, say for example, um, like 3 to 7 days. Okay. I mean 4 days, fourth day to 7 days. Then the recommendation is spinning. It is dynamically called the cloud. It says bullish. All three data sources are available and point to a strong and improving market. So it looks like it's good signal. Bloomberg index is 3550. Clark signal is optimistic, and S&P confidence 78 percentage. Okay, so in this case it says deploy. Okay, recommendation is favorable. Okay, so likewise, and if I reduce 7 to, say for example, 6, just for 2 days, 4 days to fourth day to 60-day data, it is a mixed. Okay, so still not that great because of the values. Clark is neutral. S&P forecast is 75%. Bloomberg signal is 3,300. Not that great, but it's okay. Okay. Suppose if I want to know the latest last 3 days data, I mean 8 day, 9 day, 10th day, and it will show the recommendation appropriately. Yeah, strong, bullish. Okay, so deploy 8 vessels. It's recommending. You can go for it. Okay, BD index is tremendous. It's very good number, 3,950. Clark signal is good. Broker is optimistic. S&P global confidence, S&P global signal confidence score is 85 percentage, which is above good, and everything is green. So it is good sign. Okay, so this is at high level. This phase zero implementation. I have some other two menu option here. One is audit. Audit tracks the each and every event, logs all the information whatever the user is performing here. Whereas decision history is the each and every time when your user clicks recommendation, whether it's a bullish or mix, whatever the result is, it is captured here. So say for example, if we wanted to know in the past, like on this day and time, by which user say, recommendation is bullish or bearish, we can find with the help of decision history table. Okay, so yeah, this is my minimal implementation. I have a good roadmap to extend this AI agent into various phases, but now at the moment it is phase zero only. So this is my code I used. Yeah, I have some code files, but here I have something called src. Here these are the key files. Okay, this prompts.py is the file which defines my large language model, the cloud model, how to evaluate based upon what parameters it can give recommendations. And then here dashboard.py file. This file, uh, one moment. Yeah, this file dashboard is the file which is used to display the homepage, whatever we see in the screen, and this will call um, API. Okay, application programming interface. This is the one which will create API calls. Web services call, you can say otherwise, and this one will call agent.py. Okay, and this one will call the database coordinator. This is the one layer which will call my real database residing under this folder. I'm at the moment for this application. I just used a simple SQLite database, voyage underscore intel.db. This contains those five tables, three tables each for the three data sources, one table for audit, one table for decision history. Okay, and then config.py is the file which is used by database coordinator as well as api.py file which reads the data from the environment file where I store the anthropic clouds API key and what model, whether it's clouds, haiku model or sonnet model, those kind of stuff. So yeah, this is a simple application. We can extend this. This is the requirements.exe which has all the libraries which is needed to uh, deploy this application. And then this is my roadmap. What are the plans I have in the future? I have made all these things here. Phase zero, phase one, phase two, phase three, and all. Okay, these are all my plans. And then yeah, readme file is a plain English which will be seen in my GitHub when I upload my application. Scripts is a kind of a backup script in case if I lose my database. If I run this, that will create the schema. Okay, schema and that's some mock data. Docs is about by what is the purpose of this. When I started the application, I created my own use case. So this I put it all the details under this file. That's it. A simple application, but it's having a good vision. Okay. If you have any feedback, I'm open for it. Thank you.